ahead and start. All these sessions that Roy videotapes go up on YouTube. So all last month's lectures, if you missed them, they're all there, all the way back for 6 months.
Okay, take a brief.
Pardon?
Tell us how to find them on YouTube.
Well, what I do is just go into your search engine and say YouTube, and YouTube will come up.
Yeah.
You'll get all kinds of choices. It says YouTube, click on YouTube.
Yeah.
In YouTube, there'll be another search engine for YouTube, another box. Usually a magnifying glass or something, yeah.
On the left side,
Okay.
you'll see something that says Browse
Okay.
Channels. Click that, type in MECATX.
MECATX. Okay. Okay. Well, I didn't know how to.
It's a
search.
channel.
Once you're into YouTube, you go MECATX. When you get to MECATX, there'll be another search engine somewhere up there, and you can search for drones, for example.
Okay.
Or in this case, you could put sound.
Yeah.
If not, you have to go through, you go through
Long list.
300 of them. You go down, down, down until you find what you want.
Yeah.
But it's basically 3 things to get in unless you simplify it. You're just going to do it as somebody on the outside would.
Okay. Thank you.
Okay, anyway, and the easiest way, said if you want me to start handing these out, I've got Samantha trained now to do these on Sundays. So at the end of the month, she puts them on there. I'll have her put, I guess, like February, January, December. I can give it to you. Then all you have to do is read the QR code and you're there.
Okay.
It takes 2 seconds and you'll be watching both videos. Each video, each session, Roy divides into 4. So when you find, like today, sound, it'll be part 1, part 2, part 3, part 4. So obviously, if you heard part 1 and then you went home, then you should look at 2, 3, 4. Or if you want to hear part 1 again. Anyway, this month we talk, because we're all musicians, or most of us are, we're going to talk about sound. Last month we talked about electricity. So sound is very important, especially to a musician. So I try to relate everything that we do in physics, electricity, sound, whatever, to where our interest is. My interest is health, medicine, music, and so on. So we'll try to relate it to music as much as possible. Today we'll talk about the principles of sound, and then the first one that really did a good job, in my opinion, of taking these principles and turning it into music. That's a Hammond B2 or B3 organ, which we've got here. We'll go over it. Anyway, we've talked about much a sine wave. So most things are put into a sine wave. It goes up, plus, down, minus, and this is 0. So a sine wave, you can measure lots of things. And this is basically how sound is measured, and discussed, and put into algebra, and so on. So if you look at the chart I gave you there. Got it? First, you have a primary tone. Okay? A primary tone, let's say, is 440. Look up here, you've got 440 as a primary tone. 440 hertz. Okay. That means 440 times per time slot. That is going to push through. Okay, 1, 2, 3, 4, 5, yeah.
Is the time slot variable?
No, it says hertz.
Okay.
There's megahertz, kilohertz, hertz. So
Okay.
it's just like 1,000,
Okay.
100,000, and a million. So that's so many frequencies. So for 440, it's not variable, but the next step is variable. Okay, so that's the primary sound. So if you have a string, for example, on a mandolin, or a string on banjo, or a string on a violin, let's say some strings are gut strings, some strings are steel strings, right? Steel guitar, classic guitar. But how you tone them apart is what they've got here is what they call the overtones and harmonics. So look here. This is 440. That's A above middle C, 440. Okay? So we go up an octave. I thought we were all wrong place. I'm used to touch screens. Okay, now we're at the A above what? Let's go to the keyboard again. C4 is middle C. Okay. And you have a piano C 1, 2, 3, 4, 5, 6, 7, 8. So here's what we're talking about. C4 and C5. This A right there is 440.
Now, is that the A below middle C?
That's the A above middle C.
Above middle C. Okay.
And that's where all instruments in the world have to be tuned to that. Depending on a lot of ifs and buts. There's always some ifs and buts that work the way. But when you have a tuner, you have to make sure that your tuner says 440. If it doesn't say 440, you're not going to be in tune with the people who are at 440. So let's go over tuning. Tuning at 440 is perfect pitch, right? But if you tune by ear, your pitch is not so perfect. You may think it is, but it's not. And you're tuning at 450. Then everybody can tune against you at 450, and they're going to sound good. But the guy that's got a tuner at 440 tunes against it is not. So you have relative pitch and perfect pitch. Okay. Also in pitch, on your tuners, you'll see that your tuners usually have this. This is probably red, green, yellow, and this may be green. This is perfect pitch. Okay. You may tune to this now for perfect pitch. You go on stage and you're up here. Okay, green. Strings get hot, they get cold, they shrink, hot, they expand, so the pitch is going to change. They say the mandolin, I can't remember the term, but it's always out of pitch because it's got 8 strings, like violin, and they're, generally speaking, steel strings, which react quite a bit to temperature. So anyway, these are cents, 5 cents, 10 cents, 100 cents. So you can be from here to here, and you probably won't bother any musicians. If you get down here, you're out of tune. They're not going to like it. If you get down here, you go up here, this is going to come back here, so you're going up. If you're on A here, go all the way down, back here, this is B. Okay, A plus, or B minor, B flat. Then you're back here. But anyway, you got to your tuner is within 5 cents or 10 cents. Either way, most people will say it's okay. You prefer it to be here, but it's not going to stay there. Now it stays a lot more because we have electronics. Now you have a tuner that sets on your violin, your fiddle. You look at it constantly. Okay? Or guitar players, they have a tuner on the foot. If you look down and say, oh, 5 cents off, let's get it back. Let's get back to here. And what we've done is we've gone up an octave. So now we're above middle C. Okay, this is A. Now we've gone up here to this A. And if we go up here, but let's just go down. If we go down, this is C4 to C3. But actually we're doing A4, A3, A4 is what we're at. So let's take this down. 440. Go down, it's 220. Okay? So on the 440 scale, all you have to do is double it or half it. If it's 440, you go up, and it's 880. You go down, 440 becomes 220. Got it? More or less?
Well, I think so. So then you can double the 880
Oh, yeah.
and just keep going.
Well, not only can you double it, you can get everything in between. That's what we're going to talk about now. When you have, if you look at this here chart, it's got the fundamental frequency,
Yeah,
and we're not going to talk in equations, so forget to look at the right side.
okay.
Then you have the first harmonic. Okay?
So would the first harmonic in this situation be the 880?
No, that depends on the string, the instrument, the wood in the violin, depends on the string. That's what gives us the unique sound of whatever we're playing. All these harmonics together. In this case, they've got up to the 7th harmonic, and they show you the sine wave. First harmonic, second harmonic, third harmonic, fourth, fifth, sixth, seventh.
Question.
Yeah.
Do a little explanation on harmonics, just exactly what are we talking about?
Well, look at the sine wave.
Yeah,
Okay, let me erase this and put it up here.
I mean, I've heard of them, you know, but I really not sure that I know what a harmonic is. It's a resonant sound, but it's,
Okay, let's say our fundamental that they've got here, okay, in the sine wave. Let's say this is 440. We're talking about, right?
They need to do more curves.
we can't see the stuff on the board, Doc.
I don't know.
Uh,
Murphy's Law.
yeah, I know. They frustrate the thunder out of me.
There, you're probably gonna see that.
I don't know why they didn't leave it alone, just use old chalkboard.
Okay, on that chart.
Now, there you go.
See, it goes like that.
Yeah.
Okay, so let's say this is 440.
Okay.
Then they got the first harmonic. In other words, this is, we said it's time related.
Yeah.
So many cycles per time.
Okay.
Hertz in other words, for this.
Yeah.
So many times. And go up and down.
Yeah.
The higher it goes, what? The faster the pitch. The slower, we just saw that here.
Okay.
The slower
Oh,
it
yeah,
goes,
yeah.
the lower it goes,
Yeah.
the slower the pitch.
Okay.
Okay, so low would be 220, low. High, 440, 880, and so on. Okay, now your first harmonic, in that same time frame, the first harmonic is going to do two of them.
Yeah.
So that's going to send this sound wave up, and it's going to send another sound wave, because you're using that specific instrument. It might make a little bit more sense when we get to the hand here. In the second harmonic, they've got, right? So let's just keep it simple with what we've got here. Let's say your first your fundamental tone is 440, A above middle C, on whatever string instrument you're playing. Your first harmonic is twice as much, more or less. So your first harmonic would be 880,
Yeah.
right? The next one, twice as much, it may be what?
1720.
Yeah.
0,
Thank you.
16, 1, right?
Jim says 17. Well, what?
1720.
80, 16,
440,
17,
yeah,
20,
17,
170.
880,
1720.
No, 8 and 8 is
2
6.
times 8 is what?
16.
16. Add a 1. 2 times 8, 16, 1.
And 2 times 60 is 120, so that's 1720.
So let's look here. We're gonna go up an octave, 880, and 1760. Now, you take this and go all the way down
880, I got 860.
to the 7th harmonic. This is first, second. Your chart showed you that. That will give you the sound to your ear of that instrument. So if you're playing on the violin, the fiddle, for example, you're playing A, the A string. This is what my ear's gonna hear. All these fundamentals and harmonics. So if you're gonna play it on the guitar, these harmonic, this is gonna stay the same. Fundamental will stay the same, but the harmonics are gonna change.
Now harmonics are
They're secondary
they're
tones.
secondary tones. They're in
Secondary
the
tone.
same, yeah.
So if you put out a fundamental tone, you're gonna put out many secondary tones
Yeah.
depending on the instrument you're playing.
And they will always harmonize with your primary.
Well,
tone.
yeah, they have to come off of the fundamental.
Okay.
Now, are we okay so far?
Yeah, I think so.
Shouldn't be too hard. Here, let's go
Is
back.
that an app?
Hard?
Is that an app?
Yeah, there's an app on iPad too, so you can get that app. I'll show you at the end. I have 2 or 3 of them. That one happens to be